these seminars are designed to help our undergraduate students as well as graduate level students gain exposure to the variety of areas of careers and career paths that are available to you once you finish graduating. So with no further ado, I will introduce Ann Youberg, our wonderful speaker. Thank you so much, Ann, for coming in.
Sure. Well, hello, everybody. Thanks for joining me today on this little tour of my career, basically. I am going to share my screen, and I just have a little PowerPoint here that tells you a bit about where I am and what I've been doing and some ideas for you to think about as you move forward in your careers. So I am at the Arizona Geological Survey, and we are a non-academic department within the College of Science. We've been back in the university for about 4 years now. We started out in the university and then had a stint as a state government agency, and then moved back into the College of Science as a non-academic department in 2016. So for me these days, my main connection with the University of Arizona's Geoscience department is through Dr. Luke McGuire's research group. And Luke and I collaborate on studying post-fire debris flows and flooding. And Luke's two students, Olivia Hoke and Alex Gore, are working on this project right now, as well as his postdoc, Tao Lui. And I'll talk a little bit more about what we're doing here. It's pretty exciting work. It's a young area of research, so a lot is going on with it, but we'll come back to that. At the university, or at the AZGS, I am a senior research scientist, and I am the head of the environmental section. And we do a variety of things in the environmental section. So a big portion of that is surficial or geomorphic mapping that goes along with the USGS State Map program. State Map is a big component of the AZGS's work. And so we participate with the bedrock mappers to create quads and compilation maps. We have a seismic hazards component. We actually run a seismic network across the state to monitor earthquakes, and then we also do fault studies, fault hazard studies. We have an active earth fissures mapping program, and that is to keep track of where earth fissures are developing in the state, and that's for development purposes mostly. We have an active landslide program. In fact, we just completed a project where we did some new landslide mapping between Anthem and Flagstaff along I-17 and found some pretty large landslide complexes that weren't known before. Debris flows, that's my favorite thing. Do a fair amount of work on that, mostly in relation to post-fire, and then flooding, both with just normal flooding and then post-fire flooding. So how I got here is pretty circuitous route. When I finished high school, I had never heard of geology, not once in high school. I grew up in rural Midwest, and it was a small school. And even if we would have heard of geology at that time, as a woman, I would not have been encouraged to go down that path. So when I went to college, I was like, oh, okay, I'll go into business because I didn't know what else to do. And so I first went to a women's college that was your first 2 years of general ed, and then I transferred to another university, Montana State, to finish out my undergraduate, and that's where I discovered geology. And that was a no-brainer at that point. Both my master's and my PhD are with the University of Arizona. So when I finished undergraduate, I didn't know really where I wanted to work. And I found an opportunity to go do an internship up in Ketchikan, Alaska with the US Forest Service. And we were working on Prince of Wales Island, which is this middle picture on the in the upper part of the slide here. And I worked there for a couple months only. It was just probably 3 months there. And I had an opportunity to really learn a lot of different skills that were geotechnical engineering. So we were replacing bridges on roads, and we were doing a lot of assessments that had to do with that geotechnical component. But through that internship, I was actually able then to get a position with the US Forest Service, and I went to the Gifford-Pinchot National Forest, which is down on the, in Washington, just north of the Columbia Gorge. And I worked there for several years, again, in geotechnical. So that was not just the geotechnical for putting roads in, but we did a lot of work with landslides, and we did a lot of work with finding what we called borrow sources, which was kind of a weird term, basically is rock quarries for the roads, and doing that kind of work. And then I left the Forest Service and moved to Seattle and worked in consulting. And that was more hazardous waste. And so we were doing a bunch of environmental assessments, and I worked on some Superfund sites. And that juxtaposition between working in the forest in a really clean environment and working on Superfund sites made me realize that I did not want to work on Superfund sites. I wanted to be out in the natural environment. So I went back to school. That's when I came back to the University of Arizona and did my master's in renewable natural resources, but it was really a geomorph degree. And then I worked for Tucson Water for about a year, and found out that I didn't really want to work with groundwater, and had an opportunity to move over to the survey. And I've been with the survey ever since. I've been with the survey for 20 years. So, you know, for me, it was a learning lesson as I went along of what worked for me and what didn't work for me, and taking advantage of opportunities. So these days, I really focus on post-wildfire debris flows. And I want to talk about this a little bit in the context of, this is a very, very young field. Sue Cannon, pictured here on the left, at the USGS, pretty much started this program in 1994, but it was a pretty quiet program until about 2002. And at the beginning, it was just like, so we get these debris flows after fires. It was really starting at ground zero, trying to figure out what was happening. And in 2002, so this is just what happened with fire size from 1990 on. So this is showing Arizona fires only. You can show this, it would be the same trend across the West, except if you were in California, oops, sorry. If you were in California, all the big fires would be in the last 3 years, biggest fires. But as you can see, after 2000, our fires started to get really big. And it was the same thing all across the West. And that's when Sue's program really took off. And so the work I do contributes to that program. There's people all across the West working on this. And so Luke and I are getting data from Arizona and New Mexico that contribute to this program. So the program that was developed is to figure out the hazards from debris flows after fires. So we want to know where they're going to occur, how big they're going to go, how far they're going to go, and when they're going to occur, right? And so I would say at this point, we're pretty good on the where. We're kind of okay on the how big. We're really working on the how far. That's a really big question right now. And the rain, the when, we're getting a pretty good handle on that too. So let's just go through this a little bit. So in the very beginning, when these fires started to get big and really encroach into the built environment where people were living, we would have these debris flows that would come down. Now, normally, a debris flow starts from a soil slip or a landslide, right? And so on the picture on the left here, you can see there's a scarp, and that was because the soil got so saturated, it lost its strength and it failed and became a debris flow. Over on the right is a picture of the coal seam fire from Colorado in 2002, one of the big fires that really kicked us off. And we know there's debris flows here from the deposits that were down below, but we can also see down towards the bottom of the picture, levees, and only debris flows can form levees. But there's no place where we can find failures, right? And debris flows have to have an energy punch to get them going. They're a kind of flow that just require that. They're different than floods, and it's a slurry, and it just requires that energy punch. So up until about the mid-2000s, we used this term progressive sediment bulking, which was just wrong, because you can't throw so much sediment into a flood that it becomes a debris flow. You need that energy punch. Around the mid-2000s, we actually, the guys at the USGS again, had an outdoor research lab in Colorado, and they were actually able to figure out that what was happening was these debris flows were being caused by the runoff after the fire, which is much higher than before the fire. And it was bringing these packets of sediment down into the channels, building up on the packets of sediment would catch on a step in the channel, build up and build up and build up till another packet of sediment came through, hit it, destabilized it. It was a dam burst. There's your energy punch, and the debris flow gets going. So it took us quite a while to get there. Well, almost 10 years to get there from the beginning of this program. But since the mid-2000s, things have really picked up as far as what we know. So before the mid-2000s, with this hazard assessment, what the USGS was doing was trying to come up with a way to develop a model, or to develop a model that could be run to say, where are we going to have post-fire debris flows? And in the beginning, they were looking at kind of a larger picture. So how much of the basin burned at high, moderate and high severity, and how much of the slopes greater than 30%, which is about 17 degrees burned, and what was the average storm intensity and total storm rainfall. And that kind of gets back to that idea of soil being saturated. But in a post-fire environment, it's runoff, not saturation, that produces debris flows. So subsequent work, again, in the mid-2000s, found out that there's a triggering intensity that actually produces these debris flows. And this started to come about as we got more and more data and timing data, which was really important. And so now what we focus on is the 15-minute rainfall intensity, so short, high bursts of rainfall. And then the burn severity really on slopes greater than 23 degrees. So that's quite a bit steeper than that original 17 degrees. Again, looking at it as an erodibility factor that was looked at before. So we've made pretty good advances in that aspect also. Some current and emerging topics that we're working on here. Alex is working on developing an inundation model, which is really important because we need to know where we can expect those debris flows to go and who's going to be in the way so we can protect them. Olivia is working on how that rainfall intensity threshold changes with time, that as the watersheds recover, so that we know for warning systems whether we need to tell, you know, you need less rainfall the year of the fire and more rainfall as with time with fires, the vegetation recovers. And then another thing we're looking at is as these places start to reburn, they behave geomorphically, they behave differently. And so what's going on with that? And on the right-hand side here, this is a study that Luke and I did over in the Pinaleños, where a watershed that burned at, quite a bit of it burned at moderate and high severity in 2004 had a lower geomorphic response than the same watershed that burned very little high, less percent watershed burned and very little at high or moderate, but it had a much larger geomorphic response. That's actually was one of the largest debris flows, post-fire debris flows in Arizona that I've seen. And then the other thing we're working on is doing pre-fire assessments of potential post-fire flooding and debris flow hazards. We did one for Coconino County a few years ago. We're currently working on one with the Navajo Nation and with Yavapai County, and we've just proposed one for Gila County. And the purpose of this is using those models that we already have and doing some simulated burn severity with historic burn severity and running those models to figure out who's in the way so we can mitigate those dangers now before a fire happens. Okay, so I guess my closing thoughts with what I've talked about here and what my lessons learned are with this education, you know, for me, the basic geosciences that we learn is really, it's a great building block. But I would say in today's world, you also need to know programming and some kind of modeling, whether that's just with MATLAB or whether you know Python. That's really important. That'll give you an edge up. I think generally this has always been true in geosciences. I don't think it's any different now, that you eventually will at least need a master's degree. But I worked between all my degrees, between every single degree, and there's pros and cons to that. But one of the benefits of that is that you get a chance to try out different things to work on, and what do you like doing and what don't you like doing. And I think you can do that by working for a company or an agency, and you can also do it by volunteering and interning. And for me, that was a really good way to get my foot in the door to get jobs. And it's a perfect way to start developing your network. And having a network is probably one of the most important things you can do. And so starting that as soon as you can is a really big deal. And I would also say find mentors and reach out for guidance sooner rather than later. I spend a lot of time sometimes spinning my wheels instead of asking my mentors for help. And I would suggest asking for help. And then collaborate with people outside of wherever you're working, because I think that's the best way to generate ideas. Yeah, I think that's what I had to say. This is my contact information if anybody wants to reach out to me. And I would take any questions if there are any. And if I missed anything that you guys wanted me to address, please let me know.
So I have a question. Why do you think that, you mentioned before with the graph of wildfires, why do you think that California just suddenly has so many big wildfires happening? You said within the past 3 years. Do we know cause?
It's a combination. It's part of it is land use. Part of it is forest management, but that's because they don't have the funds to manage the forest and they spend all their money fighting wildfires. And a big part of it, I think, is we're seeing that tipping point for climate change. And I think the fact that it's, you see the whole, well, our whole mountain range burned this summer, you know? And I think that's, you're looking at climate change. That's got to be a big signal here.
Hi, I have a question more about work for the Geological Survey. So I guess like when you get hired, do you get hired for particular projects, or do you sort of get hired in general and then kind of choose, there's different projects available that you can choose, if that makes sense?
Oh, that's a good question. That's a good question. I think every survey is different, but I would say the way most surveys work, and I didn't go through how ours work, I will, that typically there's a project that's looking for, that needs help, and so they'll hire someone, but that doesn't mean you're stuck in it. So the way that Arizona Geological Survey works is we have a line item from the legislature. And we use those line item funds as a match. Most of the grants that we put in require some kind of match. So the USGS runs this state map program where we map the geology of the state. We have to match that 50-50. So every dollar they give us, we have to give $1. We have to match $1. So that's how those funds are worked, and they go across pretty much, I would say probably 80% of our projects have some kind of match requirement. So if we have, say, a big mapping project starting, we need more mappers, we'll hire someone to be on that project. But if you come in and you have research ideas and you write those proposals, you can go down that path. And that's how I did it. I mean, I was hired to work on state map, and I love working on state map. I miss not working on state map. It's a lot of fun. You know, you get to go to places all over the state and you're out there mapping and camping with your coworkers. It's a lot of fun, but I'm so busy doing wildfire work now that I don't get a chance to state map. And I do that wildfire work because I developed those grants and wrote those grants and got that program going. So it's how much you want to do.
So I think my mic might be messed up. If you're being hired for a specific project, is it always a permanent position with the agency, or could they hire you for like a 1-year term until that project's over? And then it's kind of luck of the draw if you do something else, or if you put in work and do something else.
You know, that's a really good question, Alex. So when we were a state agency, I called us a consulting agency. And I would say now we're a consulting department. And by that, I mean, I'm gonna stop sharing here. We have projects that we work on, and as long as we have projects to work on, you have a job. But I would say that that is true for consulting firms too. You have to have projects coming in to work. In the Forest Service, in some state agencies, when you're hired permanently, you become a civil servant. But in most places, the projects have to come in for you to continue to have a job. And so we're always looking for projects to work on. I will also say this. When I was working for the consulting firm and I was doing that haz waste work, I would wake up in the morning and go, oh my God, I hate my job. how am I going to go to work today? How am I going to get through work? And I had great friends at work, so we had a lot of fun, but I hated the work. And with the survey, at the consulting agency, at the consulting firm, I wasn't in a position where I had to bring in work. I wasn't that high of a level. At the survey, I do have to bring in work, and I do bring in work, but I never wake up and go, oh my God, I hate my job. I love my job. It's like, oh my God. One time we had this Holocene mapping project, and Joe Cook and I had to raft down the scenic portion of the Verde River to map the Holocene deposits along the Verde River. And we were like, you kidding me? They're paying us for this? So I actually left a permanent position that was fully funded to go work at the survey, which I never knew from year to year if I would have a job. But that risk, every time I've taken a risk with taking a job, it's worked out best. When I've played it safe, it's never been good.
So I guess if you can write your own proposals and stuff and bring in your own money, then you get to keep the job.
Yeah, right, exactly, right? And you get to decide what it is you want to do. And I think, there's a lot of opportunities, I would say at every state survey, to expand. About half the surveys are state agencies and about half are in universities. And there's always stuff that probably should be getting done that isn't getting done because nobody's writing the proposals to do it.
Hi, Anne.
Hi, Samantha.
I've heard a lot of great things about you.
Oh, thanks.
It's nice to finally hear about your work from you. I'm wondering, as someone that's graduating from my master's in May, where would you advise to be looking for jobs?
So what did you focus, what was your master's on?
So I'm doing more like structural research, but it is, I do like numerical modeling as well. And I'm interested in like survey work. I would go into industry if it was in the right location. Yeah, I'm kind of just open to anything also because we're in the middle of a pandemic and
I know it's a tough time to be looking for a job. It's kind of scary, right?
Yeah, but there's little information out there on like when we should start looking, where, like if we should be checking just like USA Jobs and like Handshake, but I don't know.
Yeah, right. And that's, it took me a long time to learn how to develop a network. And I really didn't learn how to do it until I started working at the survey, and I've had hiccups as we've gone along. If you think you want to work at a state survey, one of the things you could do is just go to their websites and start monitoring what's going on and what they're doing. And sometimes those projects or those positions will be announced that way.
Yeah.
Trying to think if AASG, it's either the Association of American State Geologists or the American Association of State Geologists, one of the two, if their website puts those up too. I have been seeing positions come open at state surveys. And I don't know if most of those probably are not with universities, would be my guess. I haven't paid that close of attention. I don't think it's too early ever to start looking. And I think it's also would not be a bad idea to be looking for internships. That's a good way to get your foot in the door.
Yeah, and I actually worked for the Vermont Geological Survey before I came to U of A. And what I found, at least through Vermont, was the job opportunities were kind of like word of mouth at first. So that is something that I'm like, well,
That's the network thing, right? So are you still in contact with your colleagues back there?
yeah, it's a very
Yeah.
small survey though. So
Yeah, right.
yeah. But yeah, I guess I'm wondering too, like, what was it like for you when you were coming out of grad school? Like, what was the process that you went through?
Okay, so I'm gonna tell you that every job, no, this is not true. The best jobs I've had were because I knew someone. And so this is how I got onto the survey. I was in Bill Bull's geomorphology class when I was in my master's. It was a spectacular field class, awesome. And I was working at Tucson Water, doing stuff that I wasn't all that interested in. And I went into Gentle Ben's one night for happy hour, and I ran into a friend of mine from Bill Bull's class who had been working at the survey and was getting ready to leave. And he introduced me to Phil and said, hey, I'm leaving, so is Jeannie, who was also in the class. Phil's looking for someone. And seriously, that's how I ended up pursuing that job. And just as a note, Marie's on here, she had to sign my resignation papers at Tucson Water for me to walk across the street and work for Phil, her husband. But I mean, seriously, I think networking is, and it's like, that's a really good example of a very non-traditional network, right? It's students. It's a student got me a job or got me introduced to be able to apply and find that job.
Yeah, that's kind of been my experience. So
Yeah.
Thanks for sharing though.
Yeah.
So, Anne, for undergraduate students who will be graduating, what would your recommendation be for them? Go out and find a job and just work what you can, or should you really consider, if they're interested in this particular kind of work, should they consider going directly to graduate school directly thereafter? What are the benefits, pros, and cons?
I would say that if you don't know for sure what you want to do, go out and work. Find a job, do an internship, do a volunteer, whatever. So when I volunteered at the Forest Service, they paid my way to catch can. They paid for my food. They gave me housing, right? So I wasn't earning a salary, but I didn't have any expenses. So that's one way to do it. If you know that you want to go into structure, or you want to go into carbon sequestration, or you want to go into post-fire work, go for it. Just go get your master's. Just work on it. And if you know you want to go in that direction, I wouldn't. For geosciences, I would go and get that master's degree, because I think it'll be easier to find that job that you want to do. I didn't know what I was going to do. Anything else?
We still have 20 full minutes if there are additional questions. We don't have to take that time, of course, but we do have a little bit more time if you have any additional questions.
Hi, I have a question about your master's degree and your PhD. What would you say are the benefits or pros and cons of getting a master's and then a PhD, or just going straight into a PhD?
Oh, I think that's really personal. I never thought I was going to be PhD material, and I'm still not convinced I am, seriously. So yeah, the master's, so my master's work was up in the Apache Sitgreaves National Forest, so up by Springerville, and it was a really applied geomorphology project, and I was able to do that because I had worked for the Forest Service before I'd worked in consulting, and so that kind of helped choose that path. And then I went to work. I never really planned on getting a PhD. And then the Aspen fire happened in 2003. And Phil and I went out to Romero Pools to check out what had happened up there after a rainstorm for the US Forest Service. They had asked us to go up and check it out. And as we were coming back down, Phil was like, so is this what you want to do for your PhD? I said, me? And eventually that is how I came around to it. So for me, that was a very personal thing. You know, I never had planned on doing that. It was just, as things went along, it's like, oh yeah, this does make sense. And if I want to be doing, you know, if I want to determine how I'm going to move my path forward and work on the things I want to do, I really do have to have a PhD. You can't write many grants without having that PhD behind your name.
Thank you. That was my other question. If you could have a more research-based career writing grants, finding solutions to issues that you come up with without having a PhD.
Okay, so there are a lot of places, a lot of grants you can't write without having a PhD, but Brian Guti, who works in my group, who has a master's degree, has been incredibly successful at bringing in grants. And he doesn't go for the traditional NSF or Joint Fire Sciences or those kind of grants. He goes to the Salt River Project and places like that. So he's working with industry and getting those grants directly, and they don't care. They just want someone who's got the expertise, right? So it's, I personally don't think you need to have a PhD to get to write grants, but there are grant funding agencies who think you do have to have a PhD. So it just depends on what kind of agency you're going after to get the funding.
Okay, thank you.
Yeah. Anyone else?
Okay. Thank you so much, Anne. I really appreciate your coming and speaking to our population of students, and we had faculty and everybody, so wonderful community. And we really appreciate your coming and speaking to us about all of your experience. And if, would you mind putting your contact information up just one more time in case someone didn't get it previously? And then we'll go ahead
please
and
reach out to me if you have questions or you want to talk or you just want to, you know, brainstorm something. I'm more than happy to talk.